Hey guys, Mrs. Horn here. The topic of discussion today is our immune system. I'm going to walk you through the first, second, and third lines of defense. The chart that we have on page 44 gives a very brief outline of all of these defense mechanisms that your body has. The first and the second are considered non-specific. So these are things that are going to happen no matter what is coming into your body. They're doing the same exact things, whether it's trying to fight off bacteria, a virus, or a fungus, or a parasite. Your body is trying to do these things. If it gets to the third line of defense, that's more specific. That's a little more severe, and your body's going to have to create a unique antibody to help defend itself against the virus or the bacteria. First line of defense, your skin is a physical barrier, and your skin is your first line of keeping things in the environment and outside of your body. You have chemical things like sweat, tears, saliva. These are all things that are secreted from your skin or your mucous membranes or your eyes that they don't seem like the immune system, but they do help keep things out of your body. Mucus in your nasal cavity, in your mouth, is going to help trap microbes, and they're either going to exit your body because you blew your nose or you sneezed, or that mucus is going to entrap that microbe. It's going to bring it down to the digestive tract, and the stomach acid is going to destroy it. Your second line of defense, here's where we have some white blood cells doing some work. And I mentioned the names of these white blood cells when we were talking about the composition of blood. I had mentioned that the blood was made up of red blood cells, platelets, plasma, and white blood cells. The first type of white blood cell I want to talk about are the neutrophils. When you see the word leukocyte, leukocyte means white blood cell, and most of our white blood cells are called neutrophils. Neutrophils will help to clear the body of foreign things by entering any infected tissue. They are going to engulf, they're going to destroy microbes or bacteria, and then they self-destruct. They don't live for very long, so as soon as they go to the area and do their job, they die. Then we have the monocytes. Monocytes, there are not as many of them as there are the neutrophils. Only about 5% of white blood cells are monocytes. These will circulate in your blood for a few hours, and then they move into the target tissues of your body where they are needed most. The monocytes become macrophages, and these are really big white blood cells. They live longer than phagocytes, and they will engulf a microbe, and then they fuse with a lysosome, and we know lysosomes have digestive enzymes, and those enzymes are going to digest the microbe, maybe even release toxic nitric acid to digest that microbe. The other type of white blood cell for our second line of defense is going to be eosinophil. There's even fewer of these in the white blood cell population, and they help to defend against parasites, large parasites that it might invade by attaching to part of your digestive system. Those white blood cells are going to target that area. The natural killer cells, these are not phagocytic cell, and to be a phagocytic cell, that means they're going to eat, they're going to consume the microbe or the bacteria, and that the first three white blood cells I talked about, they are all some type of a phagocyte. A natural killer cell is not. They will attack the microbe or the bacteria until it bursts. They're going to attack the cell membrane so that the microbe actually explodes. The next phase of the immune response could be an inflammatory response. This is going to be triggered when tissue in your body is damaged. Could be a cut, could be you fell and you twisted something, you bumped into something, but somewhere tissue is damaged. The arterioles in the area are going to dilate, the venules are going to constrict. The purpose of that is to increase blood supply to the area. That area may become very red. It may feel warm to the touch. The blood is going to engorge the capillaries, and the fluid might leak into the nearby tissues, not toe shoes, but tissues. And this is what's going to cause the swelling. So if you've ever had something that's swelled up, it's because there's a lot of extra fluid in there and it really has nowhere to go. The response is going to be initiated by a chemical called histamine, which is actually also the chemical that triggers an allergic reaction. And the histamine is released by cells that are injured. The histamine is produced by leukocytes called basophils. The neutrophils, which I mentioned before, those are the first responders. They are going to be the first white blood cells to arrive to the area. The macrophages are going to come next. The pus that accumulates is made up of dead phagocytes. Those will go away. They're going to be absorbed by the body in the next few days because those are the macrophages and they don't live for very long. So I had said before, they go to the area, they eat, they do what they're supposed to, and then they die. That's what the pus is, dead white blood cells. And your body will eliminate those over the next couple of days. If an injury is very severe, you may develop a fever. The purpose of a fever is to try to inhibit the growth of the microbes that may have sped up the reproduction of any bacteria. If your body is warmer than normal, a lot of times that stops them from reproducing. So that's a good thing about having a low-grade fever, is that you inhibit the growth of more bacteria. And the last thing, so the third line of defense, here's where we get really, really specific. Your lymphocytes are going to kick into action for the specific part of the third line of defense. These white blood cells are going to circulate through your blood. They will also circulate through your lymph, which is the fluid that bathes your organs. So it's a clear fluid that's all over the inside of your body. They will recognize and they respond to very specific microbes. So they might respond to chickenpox or the cold virus or measles. They're very specific. Microbes consist of an antigen. An antigen is a uniquely shaped molecule that they wear on the outside of their cell membrane, and that's how your lymphocytes can recognize them. You have immunity cells in your body. They're called B cells, and there are some T cells. The B cells help to make and secrete antibodies that will respond to specific antigens. So if you're exposed to the chickenpox virus, which has a unique antigen on the outside of its cell membrane, your body knows how to make the antibodies for that, and which will help to counteract any symptoms that chickenpox virus may do to your body. B cells and T cells will recognize antigens because of the antigen receptors on their plasma membrane. So these unique cells in your body, their whole job is to go around and look for foreign things and then be able to identify it based on the antigen that the microbe is wearing. When a lymphocyte is turned on, when it's activated by the presence of an antigen, it's going to divide into two cells. One of them is the effector cell, and one of them is a memory cell. And the memory cell, let me just get the whole picture here. The memory cell is something that's left behind with simply, just as it said, a memory of what has been in the body, so that antibodies can be very easily made in the future if you're ever exposed to that antigen again. Memory cells have a very long life, which comes in really handy when You might need that years or months or weeks from when you've been exposed to it. The effector cells are not as long-lived. They are considered a short-lived cell, but they have a more immediate job and will identify something very quickly and start to defend your body against it, and then that's when the memory cells will take over. So that is the immune system in some very brief notes, and I hope this helps.